All right, so we're going to start with example 5, which is about the cost of fuel. So the cost of a gallon of gasoline is $2.87. We have to determine whether it's a function that is discrete, continuous, or neither discrete nor continuous. Hey, how many of you actually go and fill up a gas tank? Some of you? Yeah, some of us don't have driving privileges yet. The driving permits are coming soon. Some of us do. Hey, I always like to watch my parents fill it up because I guess I'm a weirdo and I like the smell of the gasoline. So they're like, Dad, can I help you pump the gas? Like, okay. So can you guys picture what it looks like when you're driving into the gas station, what the price looks like and the gallons? When you go in there, can you buy 1 gallon, 2 gallon, or could you buy 1.56 gallons? Yeah, can you have those decimals? Yes. What about the price? Is the price set prices, or do those include decimals that are in between? Okay, so if it includes all of those decimals in between, it is going to be, do you guys want to tell me? It's going to be continuous. Decimals like in between those whole numbers. Okay, so yes, yep. So in this situation, I always like to identify what my input is. So I'm plugging in the gallons of gas. That's going to be my input. And then the output is going to be the price. So the price you pay is based on the gallons of gas that you buy. The reason why I like to do that is because this says to state the domain and the range of the function. So now I know the gallons are associated with the domain and the price is associated with the range. Okay, and then we're going to label this as a continuous function. Okay, because there are not set values. You can have whole numbers, you can have decimals. But let's think about what type of numbers we can have for this. So when you are in the gas station, what's the lowest amount you can have? 0, right? So you could pull in and buy nothing. Be pointless, but you could do it, right? Yeah, just to buy stack. So both the gallons and the price have to be at least 0. Okay, and you can word that a little differently than me, that's fine. You can say they both have to be 0 or above, that would be fine. Okay, so when we're writing that as the domain and range, keep in mind what we talked about yesterday with those inequalities. So the gallons are going to be X such that if they have to be at least 0, do you guys want to tell me what symbol I'd have to use? Yeah, greater than or equal to 0. Great. And then since it's the same thing for the range, it's going to be Y such that Y is greater than or equal to 0. Okay, now when you're doing this for your homework, you don't have to write out the input and the output. If that helps you, you can. If you want to write this out, you can. But you only have to write those answers there. This is just to help you so that when you're going back and you're looking through and you're like, why do we say this is continuous? Why is this the domain and range? Now you have some context. Okay, this is our thinking process. So when we're doing notes, I want you to have down what I have down, but just know that sometimes on your homework, I'll write down the process and you don't have to have that to get full credit for your homework. All right, for part B, okay, it says the table is going to show you the price of each t-shirt based on the quantity of the order. And we have to determine whether the function that models the price of t-shirts is that discrete, continuous, or neither. And then we're going to state the domain and range of the function. Okay, so again, I think it's helpful to identify that input and that output so I can coordinate them with my domain and my range. And when you have a table, this is really nice as well because we know the input is most often on this left side, right? So the input and the output are here. So we can say, it says order quantity, but it's the order quantity of the what? T-shirts, okay? So it's like the number of T-shirts that you're buying, okay? Or you can say quantity of T-shirts. That is fine. Okay, your output is going to be the price of each shirt. Okay, and the reason why I'm just being specific about that is this is saying up to 5 shirts, right? This is the price of each of them. It's not the total price. That's not going to make much of a difference in term if it's discrete, continuous, or neither, but it is going to make a difference in stating our domain and range. Okay, so when you're deciding between discrete, continuous, or neither, you want to ask yourself, are these whole number values, right? Are they discrete numbers? So if it's up to 5 and 14, there's going to be no decimals that you have to worry about here. So it is going to be a discrete value. And same thing with the price. It's just even $14. It's not going to be in between two values. So this is going to be discrete. Okay, and again, we're going to write these in set builder notation. I'm going to help you with the domain and the range. The domain can be written several different ways, and you can pick whichever way you want, but I am going to show you all the ways that you can write it. Okay, so the domain is going to relate to the input here. So this says up to 5, and then 6 to 10, 11 to 50, 51 or more. So this is going to be any whole number, right? You could, technically, you could buy 0. You could buy 1, 2, up to an infinite amount. So one way you can write this is you can just write all whole numbers. You could write it out. This is probably the least likely way you will see it, but it is an answer that this book gives. So if you look it up, you would see all whole numbers as a possible answer. And then we talked yesterday about how to write all real numbers. There's a way to write like an element of the whole number set, and that would be x, such that x is an element in the whole number set, which is a capital W. Okay, so W equals the whole number set, or the set of whole numbers, just like R is the set of real numbers. Or the last way you could write it is you could start listing them. So 0, so up to 5 shirts means 0, 1, 2, 3, 4, 5. When it's a list like this, you can just list like the first 5 and then you can put a dot, dot, dot to show that it's going to continue. Okay. Now, I want you to take a couple moments and I want you to talk with your row about why the answer cannot be this. Okay, why is this not okay for B? Okay, so go ahead and talk to the people in your row, both people in your row, here too, and then talk to your people. Yeah. Because that's what yeah, so you can't put it. Yeah, that's yeah. So, I agree with you. Good. Like a lot of you were able to verbalize why this cannot work, because if it's just greater than 0, that's going to include numbers like 1.5. And are we going to have 1.5 T-shirts? No.
If you want one.
Even a crop top is one t-shirt, okay? So it's not going to count. Okay? Down the center. Nope, they are not selling those. All right, and then for your range, like that. For your range, your prices are here. I'm just going to write them in numerical order. You can write them in the order they come in. That is fine. But it's either going to be $4, $6, $9, or $14. Those are our only options there. Okay, so the range is 14, 9, 6, or 4. Neither. You'd have to have like a mix. Like maybe one of them would be decimals and the other one would be whole numbers. Like you'd have a mix of them. So I'll try to think of a situation that will model that. Like I can see the graph in my head, like what we did yesterday, but I'll try to come up with a situation that would be a good representation for that. Right, and then for part C, I want you guys to read through that, and then I want you to just do this on your own, so take some quiet time to do that, and then do state the domain and range. Okay, so I want you doing that on your own, giving that a try. Just let them know it's okay if you're not sure. All right, so just like on the last table, we have the input and we have the output here. So the trial and then the number that is generated. So if you look at the trial, they're only those whole numbers. The output is only those whole numbers. So this is going to be discrete. Right? It's not going to do any of the numbers in between. Okay, and then your domain is going to be the list of all of your input values. Okay, so we're just going to list them 1, 2, 3, 4, 5, 6, 7, 8. Now, a couple people asked me this question yesterday. When you have a value that repeats itself, if it appears more than once, do you have to write it more than once? I told some of you yesterday. No, you don't. So if a number appears more than once, you only need to notate it one time. It's kind of like what?
The one we just did. The one we just did with the t-shirt.
Yeah, like you wouldn't have to list it out for like up to 5 times.
Or up to 51.
Yeah, 51 or above. Okay, so I just wrote a little note. If a number appears more than once, you do not have to repeat it in the domain and range. Okay, once it's part of the domain and range, it's already in there, which is going to be helpful because a lot of those numbers do get repeated. So what's the lowest number we have? 1, yep. And then there's no 2, and then it goes to 3, and then you have 4, and then 5. Is there anything higher than that? Nope, so it's just 1, 3, 4, and 5. Okay. All right, now for examples 6 and 7, we're writing the domain and range in two notations. So we did both of these notations yesterday. We are doing set builder and we are doing interval. So we did set builder in example 1 yesterday. We did interval notation in example 4. Today we're going to write it in both. Okay, so we're going to look at A, B, and C first. Then we have D and E on the bottom here. Whenever you are doing the domain is your x values. And the x-axis runs from what? Left to right, okay? So if you look at these arrows here, you have one arrow on this side, you have one arrow on this side, and there are no breaks in the graph. Anytime you have an arrow on the left and an arrow on the right, there's no breaks in between, your domain is going to be all real numbers. So on the left, it goes to negative infinity. On the right, it's slowly approaching positive infinity. Okay, so when we're saying that in set builder notation, it's x such that x is an element of the real number set, which we did yesterday. And then today we're going to learn how to write that as an interval. So see how in the left we said it's going to negative infinity? That's going to be the left part of your interval. And then what's the right part? Positive infinity. And you can just write it just like that. Okay, so you have negative infinity to infinity. Anytime it's all real numbers. Okay, now when you're doing the range, why don't you actually give that a try? Even if giving it a try is just looking at it and thinking about it. Okay, if you aren't sure where to start with this one, remember for domain we were looking at left to right. For the range, we're going to be looking from bottom to top, or lowest to the highest. Okay, so the lowest value here is going to be negative infinity, because this arrow is pointing down. This arrow is pointing up. So positive infinity is the highest point, which means, again, we have those all real numbers. So it's y such that y is an element in the real number set. Okay, so this is negative infinity to infinity. Okay, so I'm going to give you guys a moment. I want you to try part B on your own. Again, we're doing that domain and range. And see if you can put it in both notations. If you're not ready for that, that's okay. At the very least, get it in that set builder, okay? I'm trying to put that here. Okay, so again, you're looking from left to right, okay? So what is going to be the point that's furthest to the left? Negative infinity. And then furthest to the right? Yes. So again, when you see these arrows, okay, and it's not, and it's continuous, okay, if it's continuous and has those arrows, you're looking at an all real number situation. Okay, so for C, is that continuous? Is that a continuous graph? Can I draw it without picking up my utensil? Yep. Do I have arrows on both sides? Yep. So guess what my domain is going to be? All real numbers. Okay, and anytime it's all real numbers, your interval notation is just negative infinity to infinity. We're going to be practicing those figure eights there. Sometimes they look better than others. Good. Okay, and then just while we're looking at those, let's look at D. So D has the arrows on both sides, but is it continuous? Nope, so it's not going to be all real numbers. Okay, and this one doesn't even have the arrows, so that's not going to be all real numbers. Okay, if it's continuous, arrows on both sides, all real numbers. Okay, and if you want to write that, because you like seeing it, if it's continuous and arrows on the left and right, that means the domain is all real numbers. I'm just going to write it like this for shorthand. Okay, and feel free to write those notes for yourself. Okay, now for the range, we are looking at the lowest value to the highest value. So in terms of the lowest value on the y, I'm going to be right here, which is at -5. The highest value, I have these arrows, so the highest value is infinity. So what we did yesterday is we wrote that in set builder notation. I asked you to look at this and see if all the points are above a certain value or below. So all the points are above -5, which means we're going to use what symbol? Yep, greater than or equal to. Okay, so y is greater than or equal to -5. Okay, and then we did a little bit of the interval. The interval notation, same thing. You are always going to start with the lowest value. So your lowest value is -5. We're going to use a bracket. You're always going to use a bracket unless there's an open circle, which we aren't even looking at that yet. And then your highest value is infinity, so that's it for your interval. Okay, and then for this one, I just want you to identify on your graph what's your lowest y, what's your highest y. Okay, on your graph, just make it visible. What's your lowest y, what's your highest y. All right, so the lowest value is what? -1. Sorry. The highest value is 1. Okay, so when you're doing this, it might be easier for you to do the interval one first. So I'm going to put it below here. Okay. And then you have the arrows based on this pattern. The pattern's going to continue. So the lowest value is going to be -1 and the highest value is going to be 1. And again, that's based on the pattern that we see here. This is actually a special function. Do any of you know what it is?
It's called a special function.
It's trig. It's trigonometry.
The cosine and
It's a sine. Yes, yes. But you guys did a little bit of that in geometry, and we'll do more. It no, it's something we'll learn at the end of the year. So when we are writing that out in set builder notation, we are going to write, these are all values of y such that -1 is less than or equal to y, which is less than or equal to 1. So that's how you notate that something is in between. So it's in between -1 and 1. Okay, so all the values occur between -1 and 1. -1 is less than or equal to y, which is less than or equal to 1. Okay, so anytime you're doing this, just remember, it's lowest to highest. If you put like the 1 first instead of the -1, that wouldn't be correct because the lowest does have to go first. Okay? All right, now we did a little bit of this yesterday, and I know that was new and scary, and how brave of us to try something new, and today we're gonna finish that. So when you are doing your domain is always left to right. We already talked about how this is not going to be all real numbers because it's neither discrete nor continuous. So what we are going to do is we are just going to go from left to right and find where those bounds are. So this arrow here is a -infinity. And I'm going to do the interval first because I just think it's easier. Okay, so if I'm looking at my x values, the arrow says -infinity, and then that's going to keep going until I reach the value of 1. So that is my first interval, -infinity to 1. Do you guys remember from yesterday what we used when there were 2 intervals to link them up? A union. Okay, good. All right, and then this next interval picks up at the number 3. So that's going to be the start of our next interval. And it's going to go to infinity and beyond. All right, so we did it. Great. Now let's put it in set builder notation. Okay, so for the first one, what we're saying here is that all of these x values, okay, and again, we're talking about x. So all of these x values are to the left of 1. So that means they're all below it. Okay, all those values are below 1. 0, -1, so on and so forth. Okay, so the way that we would say that is x is less than or equal to 1. Okay, and that's just for this part here. All of the numbers are below 1 on the x-axis. This union means or. And or implies that something can't happen at the same time. So it's either that these numbers are less than or equal to 1 or they're above 3. So it's or they are greater than or equal to 3. Okay, so there's no number that's both less than 1 and greater than 3, which is why we're connecting it with that or value. Okay, and then do you guys want me to, for the set builder, you put the or. And then for interval, you put the union. Do you guys want to try the range on your own without me telling you first?
Yeah.
Okay, so I'll just give you the hint that you do lowest to highest. So why don't you try to do the interval? So interval notation has the parentheses or the bracket. Oh, well, this one is kind of hard. Maybe just identify on the graph where the lowest value is and where the highest value is. Okay, do that for me. Where's the lowest value? Where's the highest value? Okay, so now we're looking up and down. What is the lowest value? Negative infinity. So this down arrow is telling us it is negative infinity. Okay, and that is going to be the first part. The reason I told you that all this could be a little bit difficult is because if you're just looking at this interval, right, this isn't our highest point, right? This -1, because what does this arrow mean? It's going to keep going down. So see how those are going to overlap each other here? So this isn't the lowest point, or this isn't the highest point. What is the highest point? 1. Okay, so this is going to go from negative infinity to 1. Okay, there's not going to be a union, and that's because there's no gap here. Sometimes there is a gap. If this arrow was going in the positive direction, you would have a union here. But if there's no gap, there's no union needed. Okay, so if there's no gap in between those, there's no union needed. Okay, you can also think of it as, oh, if they overlap each other, you don't need the union. Okay, there's no gap because this is going to keep going down. Okay, so then when we write this in terms of set builder, all of the values are below 1. So we would say y is less than or equal to 1. All right, I'm feeling good at letting you try the domain in your interval notation. And if you want to try the set builder, go ahead and do that as well. If you're feeling hesitant, that's okay too. Okay, but I do want you to try to do the interval notation for both the domain and the range. Right? How confident are we feeling on this domain? Okay, so we're going to start with the left. So what is the lowest number on the left? Yes. Okay, so when you're looking at the lowest number, right, the one that's most to the left is here. Okay, so we're going to do 0, And then the next number it connects to would be 1. And then there's a gap there, right? It's not continuous, it's not discrete. So then we're going to do a union, and it picks back up at what number? Nope, 2, yep. And it goes to 3. Okay, and then I asked you to try, if you wanted, the set builder. I'm going to write this underneath because it's kind of long. So it's x such that, so we're just going to do 2 of them. The way that we say something is in between those is just like how we did it up here. See how we said y was in between those two? Okay, so if x is between 0 and 1, it looks like this. 0 is less than or equal to x, which is less than or equal to 1, or x is between 2 and 3. So 2 is less than or equal to x, which is less than or equal to 3. Okay, now we switch gears and we do the up and down. Okay, so we're going to start with the lowest. Yep, so the lowest value that we have is -3. Okay, and there's no arrow, so we don't have to worry about the infinity. Now, when you go to the next one, right, this is your highest value, but do you see how there's a gap in between there? So we have to use a union here. If there's a gap, you're going to use a union. So this goes from -3 to -1. So that's a little trickier. Okay, and then if you have a gap, which when I say gap, I mean there's nothing here, right? Okay, so if there's a gap, you need to use a union. Okay, and then that will go from 0 to 1. Okay, so if you weren't able to get that, that's okay. I want you to try to do those two from there. So anytime you have those intervals and there's no infinity, you are always going to put them in between. And again, you're going to connect those with an or. Okay, and you have your fancy brackets. Okay, so for today, if you already did yesterday's assignment, like if you already completed that, the 1 through 4 and the 7 through 12, then you're only going to have to do 13 through 21 today. We're going to submit that in Google Classroom, and I'm going to pull this up on your camera.